Neutralization reactions are what happens when you have a reaction between an acid and a base, and the proton is transferred from the acid to the base. And many of these neutralization reactions are just metathesis reactions that happen to occur with acids and bases. And these are the ones that you're most likely to have encountered before. Things like an acid reacting with some sort of metal hydroxide. And I'll give you a few examples. So of these 4 examples, in each case, at least one of the acids or the bases is a strong electrolyte. In the first 2 examples, both the acid and the base are strong. So the HCl in both cases is a strong acid. I've given it the abbreviation SA. And NaOH is a strong base, and calcium hydroxide is a strong base. In the third example, HCl is still a strong acid, and magnesium hydroxide is a weak base. And in our final example, phosphoric acid is a weak acid, and calcium hydroxide is a strong base. In each of these examples, we have an acid reacting with a metal hydroxide. And again, these are metathesis reactions, so you simply trade cations and anions. So in this example, we've traded the cation and anion. We've made HOH and NaCl, and typically we write HOH just as water. And for completeness sake, we should really remember to include states of matter. So HCl and NaOH are typically going to react in an aqueous form, and they'll produce liquid water and aqueous NaCl. And while we've shown the sodium chloride to be associated, it's important to remember that aqueous sodium chloride really exists primarily as aqueous sodium ions and aqueous chloride ions. So the products of all the other examples can be found in pretty much the same way. We simply switch the cations and anions, and we balance the reaction to make sure we have the appropriate number of atoms on each side. And please note that the calcium phosphate in the final example is going to be a solid, and you can confirm this by checking the table of solubility guidelines. So a commonality between all of these different examples is that whenever you have an acid reacting with metal hydroxide, you make a salt and water. Each of these examples gives you water as a product and some ionic salt as the other product. And while this is certainly a very common type of reaction, not every reaction will be quite as clean. Consider the case of ammonium ions reacting with sodium hydroxide. In this example, NH4+, the ammonium ion is the acid, and the sodium hydroxide is the strong base. And acids react with bases to neutralize by transferring a proton from the acid to the base. In this example, the NH4+ is going to transfer an H+ ion to the OH-. Now this example is a fairly common representation of a metathesis neutralization, but it's a little bit sloppy. And it's sloppy because we've shown some things as ions and some things as intact ionic compounds. The NH4+ is shown as an ion, but the sodium hydroxide is shown as an ionic compound. In practice, we should really write everything as ionic compounds or everything as the separated ions. So it makes sense to do things as entirely molecular reactions or entirely as ionic reactions. To make a little bit more clear what's happening, I'll do it as a total ionic equation, where the sodium ion is a spectator ion. In this case, we still produce the NH3 in the water, but we've eliminated the sodium spectator ion. And it's important to note that this still produces water, but in this case, unlike our previous set of 4 examples, while we make water, we don't also make a salt. So while salt plus water are common products, they're not exclusively what you can get. And continuing on this trend of reactions not always giving you salt plus water, there are a number of different bases that will react with acids to produce a gas. And I'll show you a couple of examples now. In the examples on the screen, we've simplified everything to the net ionic equation level, where the acid is shown simply as H+, and the bases are shown as their anions. In the first example, you can see that the product of the acid and base neutralization is H2S, which is itself a gas. In the remaining two examples, the neutralization reaction gives you H2CO3, which is carbonic acid. Carbonic acid in and of itself is aqueous, it's a dissolved acid, but it decomposes on its own to form water and carbon dioxide gas. And this type of reaction will happen anytime you have an acid reacting with something containing the sulfide, bicarbonate, or carbonate ions. And at least one of these should be familiar to you. The middle reaction, acid plus bicarbonate, is a classic example of science that's done at an elementary school level. This is your traditional baking soda and vinegar reaction.